Okay, so we have problem number 6. We are given a 3 kilogram rod with a length of 0.5 meters, and it is fixed at one end and is allowed to rotate around this fixed point with negligible losses due to friction. So for part A, we need to find out what the rod's minimum angular velocity or angular speed of the rod at its lowest point or vertically downward, such that the rod is able to reach the orientation when it is vertically upward. So to do this, we need to find its moment of inertia, and moment of inertia for a rod is equal to 1/3 times the mass of the rod times the square root of, or the length of the rod squared. And then we have this algebra here, and the moment of inertia for the rod is 0.25. Then we could solve for kinetic energy, or rotational kinetic energy, which is 1/2 times the moment of inertia times the angular speed squared. We don't know the angular speed squared yet, or the angular velocity yet, so we solve for kinetic energy in terms of angular velocity. And then we are given, we need to find its total kinetic energy, which will be equal to the potential gravitational energy, and that's mass times the rate of gravity times its height. And then we get that is equal to 14.7 joules. So the rotational kinetic energy will be equal to the potential energy of gravity, which is 14.7 joules. We set that equal to what we got for kinetic energy in terms of angular velocity, and we solve for angular velocity, which will equal 10.8 radians per second. And then for part B, it's very similar, except in this scenario, if the rod has the angular speed we determined in part A, which is 10.8 radians per second, but the rod only reaches an orientation where it's horizontal, and we need to solve for how much energy has been lost due to friction. So it's very similar here. We have its total potential energy of 14.7, but since it's horizontal, perfectly horizontal, will only require half of that energy, and so the total energy lost due to friction is 7.35 joules.